Okay, guys, thanks for joining. So we can start today's session. So if you attended last session last week, we have been discussing about ROS projects. Okay, so today's session, I think we can conclude with the ROS session. ROS project. But I think it will be useful. This chapter will be useful because I have planned to give some project list to you, but I have some list, but what I am interested is that like you guys can come up with different projects. So that's what my idea. But if you can't able to create some cool projects, then in this session I will be giving like some list of projects and also how to think about ROS project, like to fill your portfolio. So I think last class, I think I have been talking about the GitHub portfolio. Maybe I can switch to my some reference. Just a second. Let me log into. Okay. I think there is a question. Yeah, guys. So finally, we are discussing the projects. I know it's. I mean, we have. I mean, I have actually delayed, but let's see. Okay. So just a second. We have a lot of people actually. It's a collaborator. Just a second. By the way, like I just want to give you access to this folder. So if you join this course, you will get access to this folder. This is having all the books that I have written, the soft copy, and also some of the books that I have reviewed. Okay, so you will have access to this. If you don't, maybe I can share it now. Just a second. So you can also take it. Just a second. I'm just sharing the link. Not in the group, maybe here. Okay. So you can try to take that. Let me see whether that is working or not. In the meantime, I can take some reference GitHub portfolio, and we are trying to create a portfolio like this. Wait a minute. Okay. And you can take these two books, that is ROS Robotics Project and this one, the book without having a thumbnail. So that is ROS Robotics Project second edition. So I will just go through it. So before that, I just want to show you several portfolio that you can take a look. Wait a second. Okay. Okay. Yeah. I'm just searching for some people who already done the course, the first course. Okay, I think that will be enough. So yeah. Okay. There is one more guy. Okay. Yeah. So I think I have enough things to discuss today. Yeah. So there is a question only book area is accessible, not the folder. Oh, okay, okay. Could you please share the folder? Okay, okay. Sure, sure, sure. I will do that. Just a second. Okay. Let me share the link. Okay, so can you try this? I have given another link. Uh, Let me know that is accessible, the entire folder. So if you are getting it, just let me know. Okay. So this, okay, great. Okay, thanks. So this is the folder, and just a second, this is my, okay. Uh, all of the books are related to ROS 1. So we can take, for the projects, we can take ROS Robotics projects, ROS Robotics project second edition, then ROS Robotics by examples, then yeah, so that's it. These three books we can refer. Um, so maybe I can start discussing. So the agenda of the this session is like how to create the portfolio by doing projects. So from this course itself, a lot of students asking me like how, like when you apply for some internships or apply for a job or apply for master's program, um, it is essential that like the projects or the portfolio that you have created so far. Okay, so some of the portfolio can be some learning projects. Some of the portfolio are like some unique projects that you have done. So whatever it is, you can put that in GitHub and create a profile like this. Okay, so these are some of the students that enroll in the last batch, and they all follow the same procedure, and they have created some unique projects as well. Okay, so these are the projects that they have done uh, as a part of the course. And these projects, no, these projects are not suggested by me. They actually come up with this. So this is, I mean, there was some kind of award at the end of the course. So this is actually one of the promising ROS project, and there are some other best project for France. He got the best developer award or something, and Jerin also got. So Jerin was also one of the uh, uh, team member. So these are some of the project that Jerin did as a part of the course. Okay, from the basic projects, basic ROS nodes to some advanced robots like this. Okay, and the Drotter is actually the founder of ROS Agriculture. I'm not sure how many of you heard about ROS Agriculture. So he was also there in the last course. Yeah, he didn't populated his portfolio, but he's having enough projects, I think. Yeah. So yeah, this is another guy. He actually contributed a lot to his profile. Basically, the good thing is, I mean, this guy, no, he's already enrolled in the second course as well. Okay, he knows a lot of stuff, but he's also joined, and he's also working in different domains, not only in ROS. So, but he actually worked hard to create so many projects into his portfolio. Okay. Yes. So what I will do is I will share these links in the discussion channel first, so you can have a look. So um, that is the intention for you as well, creating the portfolio mainly through Git, or you can create a blog in Git. There is an option to create blog. I think I have discussed that. Just a second. I'm just sharing, copy pasting the links. Okay. Okay. And we can also see some of the popular developer profile. Maybe Steve Kens or we can search for navigation 2. Navigation 2. So I have shared some of the portfolio that those guys already enrolled in the course. Maybe we can see some of the core developers in ROS. For example, navigation 2, which is actually the navigation stack for ROS 2. So this guy, I mean, he's very popular. He didn't, updated his profile, GitHub profile, but he's having enough repo. Just a second. Yeah, awards in the sense, so there is a question, are the awards by Robo Academy? Yeah. So it is just for the motivation purpose and also for the performance. I planned for the awards because they actually did a great job for the projects. So again, in the last course, in the last batch, there are like 30 to 40 students, but these guys actually performed exceptionally good. So I should give something to them. Okay, so that's why I planned for awards, and I shared it in my network as well because they actually performed well. So this batch also we can do something like that. It's basically based on the projects that they have done. Okay, I just went through these projects and I just evaluated. So we can see the hard work they have put to create a portfolio. Okay, so that's how the award ceremony actually happened. So this guy, you can see from this contribution chart, you can able to find he's very active in the GitHub. That means he's contributing something, and these are the organization he's contributing: ROS Perception, ROS Planning, ROS GPP, ROS Device, ROS Geographical Open Robotics, ROS 2 Release, Jetson Robotics, then Samsung. He's working on Samsung. So he's the main author of Navigation 2, and by looking at his profile itself, even though he actually given basic details, we can find most of the stuff maybe from his website on the left side, or the main project that he has working is this Slam Toolbox, then Navigation to all are his project. So these are some of the way to get like present ourselves. So you can see here some of the publication he have done, then some ROS awards from Construct. So this is how you can also create a website, and in the projects you can find you can put the important project that you have done. Then the publication, I think he didn't updated anything, but the publication is having tons of publication. Yeah, these are some of the robots he's working on. Great. It's interesting. Okay. Yes. So yeah. So that's a thing, guys. And we can also check some of the developers from the main popular projects. These guys are not very update. They didn't updated the repo, but they are working on some core things. Anyway, like as a beginner, I will suggest you to update the portfolio, GitHub portfolio, update the social media links, YouTube, everything. Okay, so that is how we can do the portfolio, and now we can get start to discuss the projects. Okay, let me close all this stuff and just focusing on this. So this was the book I have written in 2016 or something, called ROS Robotics Project. This was the first version of this book, and I actually work hard to write this book. This is a single author book, and you can find I have worked like in the 10 projects only for writing this book. So it was not like the project that I have done earlier. It was actually like creating projects for the book, for writing the books. It was actually challenging because this project should be very interesting. It should be unique from the rest of the projects at that time. Okay, so if you check this kind of project, you can't find this kind of project. Okay, so I worked with the ROS Kinetic 16.04 at that time. It was the latest version, and you can find how I organize the projects. So this is not a book discussing the projects. What I did was I started with the first chapter, which is having the basics of ROS, like what is ROS, what are the concepts, then basics commands, then how to set it up, all this stuff. Then I started with some cool projects. So in the first chapter itself, you can find some node based projects like Talker, Subscriber, Publisher, those stuff. And in the second project, we are starting with some cool projects like face detection and tracking using ROS, OpenCV, and dynamic cell servos. Like it's very simple. Like there is a webcam mounted on a servo, and when you move the face, the camera will be tracking you. Okay, very simple. But in order to implement that, it will take some time actually. Okay, so I was using ROS, OpenCV, and dynamic cell um, driver for working with that. I will discuss that project. Okay, but I'm just going through this list. And then another interesting project like building a Siri like chatbot in ROS. So this was actually one of my final year project in my bachelor degree. It was a part of that robot, like a chatbot basically. So there is a technology, very primitive technology, but it's still using AIML. It stands for Artificial Intelligence Markup Language. It's very simple. It's like a database. It's better than database, I will say, because in database we can only store some predefined data, but this is like an XML file, and you can create multiple combination, and also the final output will be like the output looks like intelligent. So if you just give a hi, then it will be responding with some intelligent reply. There are some AML based chatbot. I think this is based on AML. Maybe you can simply chat. Yeah. So when you just enter hello, it's responding to hi there. Then my name is Lentin. So it will, how are you, Lentin? So it's asking, how are you, Lentin? Okay. I'm fine. Thank you. That always good to hear. What's new? I'm just asking, what is your name? So it's very, my name is Anna. Glad to meet you, Anna. Nice meeting you too. So, it feel like you are interacting with Google Assistant or Siri or Alexa, right? But this is happening way before that. Okay, the technology is very very easy, and it's somewhat primitive as well, but it will work. It actually work in many occasions. So in this project, what I did was I actually created simple nodes, and you have seen the talker and listener, right? So I created a chatting node. Chatting node means I can chat from one node, and it will be sending to another node. Okay, so both these nodes having AIML based knowledge base. They have AML based data files, and if one node is having AML and I am actually the human, then I can chat with this AML bot, okay, which is using ROS publish and subscribe for communication. Okay, so that is the intention of this. I was using Python PyAML module, and it's like a talker and listener, but one node is having AI. Okay, yeah. So, and the fourth one is controlling embedded board using ROS. So this is not exactly a project, but it's basically like controlling Arduino board from ROS, then like running ROS on Raspberry Pi and or Droid boards. Then there are few projects like blinking LED in Arduino and also Raspberry Pi using ROS nodes. Okay, so these are some examples. And not only Arduino, I'm discussing STM32 board, Tiva Launchpad, all these boards using ROS. Okay, so that was the chapter 4. And chapter 5 is teleoperator robot using hand gestures. Yeah, so this is another interesting stuff. So I have been using, I think this project writing on 2016-17 time. So I was using an IMU, an Arduino. So the IMU is the name of the IMU is MPU9250. It's interface to the Arduino board. Okay, and then Arduino board is communicating to ROS via ROS serial interface. Okay, and using this IMU now, using the IMU angle, I can compute the angle, right? So using that IMU angle, I'm converting that into transform, and then I'm generating twist messages. I hope you heard about the twist messages, meaning the linear and angular velocity. So for example, if you are moving your hand down, maybe it is like linear. If you rotate your wrist, then it is angular, something like that. So it's just for some hobby, kind of hobby project. Yeah, so how did you calibrate the IMU? Yeah, so in Arduino, there is actually some automatic routine to calibrate the IMU. So I have done the basic calibration in the Arduino library for working with MPU. There are some calibration routines. So I will be putting the IMU, then running that, and then taking. So that is only the calibration I have done. Tejas, yeah. It's a 9DOF, I think. You can simply search MPU9250. It's a 9DOF. It is having magnetometer. Yes, I think it's 9DOF. I think it's available now also. Yeah, 9-axis. It is having the magnetometer. Yeah. Yes. So yeah, that is so. In this project, it is involving various things like interfacing of Arduino to MPU 9250, then interfacing of Arduino to ROS. Then after getting the data in ROS, the TF, then twist message, and then the twist message is controlling some robots, maybe the turtle sim or robot in simulation in Gazebo. Okay, so in chapter 6, there is object detection and recognition. So it's also an interesting stuff, but it's not valid. I think the find object 2D is still there. So the chapter is discussing 2D and 3D object detections. Okay, so the 3D detection was based on 3D measures. For example, if you upload, or if you have the 3D mesh file of the object, then the 3D object detection use that mesh to identify the object. Okay, so the reference is actually the mesh file that you are giving. For 2D object detection, it is mainly using the features. I mean the image features. Okay, and now the 7th one, deep learning using ROS and TensorFlow. I think I was actually the first guy who created this project. I mean, popularized this project, because there are some developers who created some interface for TensorFlow and ROS, But it was not very popular. Then what I did was I just forked that repository and did some minor changes, and then I actually documented it. Okay, so then I mean, when you put something on the book, it will be like catching up, right? So that's how for this project. The project that I have taken, that was an existing project and did some minor modification, but that project actually went well. Okay, so it's like giving some reach to that existing project, and some demo using that. I'm discussing not only the TensorFlow ROS interface but also scikit-learn, SVM. That also, like, I actually done without an existing project. I have replicated from a Python file. I mean, there is a Python code. I actually ROSify that code. Okay. Yeah, so chapter 8 was about ROS and MATLAB and Android. So it's an interesting stuff. I actually work hard to make it done. The ROS and MATLAB, it's actually like an there is a module in MATLAB to work with ROS. So if you install ROS on Linux and MATLAB on Linux, you can install the ROS module or robotics module in MATLAB, and then you can communicate from MATLAB. That was interesting. And then after that, Android and ROS interface. This is one I really liked. Like, you can create Android application with the help of ROS Java. So there is a thing called ROS Java. So you heard about the ROS EPP and ROS Pi, right? So there is ROS Java, which is actually the ROS implementation, ROS concept implementation of, ROS implementation in Java. Okay, or if you search for ROS Android, also you can find many stuff. Yeah, there are existingly there are apps in ROS. Just a second. Yeah, you can find here. These all are based on ROS Java. Basically, it's a app, and this app can be connected to ROS in the PC. Okay, and it can be act as ROS master as well. So it's very interesting. Maybe I can share this link. So I was actually creating another application, ROS application, which can communicate between ROS and Android phone. So basically, that's a very useful stuff, I will say. Why it is useful? Because just a second. Yeah, it is quite popular. You can find 331 stars. Okay, so why ROS Android went popular? Because the ROS Android or ROS application on Android can act as a bridge, meaning in your Android phone there are multiple sensors like IMU, then light sensors, mic, everything is there, right? So by writing an Android application, you can access all these sensors, and then you can pass it to the ROS environment. You can publish as a topic, and that sensor value can be subscribed to another laptop and do some processing. So meaning you can simply use the Android phone as a computer, and you can use the Android phone as a PC, or I mean not PC, the brain of the robot. So you can simply put the mobile phone and start an application, and the robot will start working with the Android phone. Okay, so there are many robots that is working like this way. They may be using ROS, or they have Android APIs that is doing the job. So creating a robot or working with a robot which is completely working using Android is very easy, but it is limited in some sense because we can't interface high-end sensors like LiDAR. LiDAR I think we can do, but if we are planning to interface like external cameras, maybe we can make use of the mobile phone camera. That is a way. but external interfacing is slightly difficult. We have to like customize the Android, like there may not be drivers available. Okay, but it's cool actually working with Android phone and robots. Okay, so ROS Android interface. And on the ninth chapter, it's basically an autonomous mobile robot, like building complete instructions from the design. Yeah, and 10th one is creating a self-driving car using ROS. So basically, this is one of the chapter that got much attention because at that time self-driving car is very hot topic, and I have actually gone through several research papers and tutorial, and then like condense everything into one chapter. So this chapter discussing the sensors that we can use in the self-driving car, then how to simulate the sensors of self-driving cars in Gazebo, and yeah, popular framework. And also this chapter I enjoyed it because even I am very interested to work in this domain, so I really enjoyed writing this. So it's having a lot of interesting stuff. And then chapter 11, teleoperating a robot using VR headset. It's again an interesting stuff. Basically what happening is that it's the objective is moving the robot, teleoperating the robot. And how we are teleoperating? We have a VR headset, okay? And using the VR headset, we can see the robot camera. Like there is a camera mounted on the top of the robot, okay? And this view, okay, and the robot is simulating. It's not the actual robot. We can use it in the actual robot, but I have tested in the simulation. Okay, so in the VR headset, I can see Gazebo, 3D view of the Gazebo. Okay, in VR headset, and using the leap motion. I'm not sure you heard about the leap motion. I still have the leap motion with me. I mean, in 2000, yeah, it's founded in 2010. It was very popular. I'm not sure. I think I have shown you some video of leap motion. It is for gesture control. Using gesture control, we can communicate with PC. So like using fingers or using your, yeah, basically using fingers, you can mimic a mouse, keyboard, all this stuff. Okay, it actually was a viral gadget, I will say, but I'm not sure leap motion is still there. Let me check for leap motion. I think they have closed, but it's an interesting technology. It's basically using IR for tracking, and we will get the complete ultra leap. I think the current, yeah. So here, oh, okay. So what I did was, so currently they have the VR with the leap. I have done the same thing but separately. Okay, so the leap motion sensor I have with me is the first version of the leap motion. This one. Just a second. Yeah, this one. So basically, we need to connect these gadgets to USB 3, and there is an SDK and there is an application that can track your fingers. Okay, it's actually very interesting. You can play games using it. It's cool, but I'm not sure it is useful in daily basis. But I think if you integrate leap motion with the VR, then it is useful because you don't need to work with the joystick. Like if you are working with VR, then one of the challenge is how to track the fingers. Okay, so leap motion can actually solve the issue. Okay, so this is one of the setup that we can use in order to track. So using leap motion, we will get the gestures, and that can be put it into the VR environment. Okay. Yes. So teleoperating using VR headset and leap motion. And by the way, this VR headset, no, I use very cheap VR headset, and inside that there was a mobile phone. So how I did was, um, in the mobile phone there is a ROS Android app which is subscribing images from Gazebo. Okay, like from Gazebo we are getting camera images, and then that is subscribing in the Android app. Okay, then it's not only subscribing, it is actually putting two images like the VR. Maybe if you work with VR headset with mobile, you may have seen, um oh, just a second. You can put a mobile phone inside the VR headset like this. I think I have bought this VR, and you can split the screen like this. You can see the font, right? So if we put the screen in a certain aspect ratio, and if we put this font inside the VR headset, it will looks like 3D. That is the main purpose of VR. So that's how I achieved this thing. Okay, yeah. And the 12th chapter is about like controlling your robots over the web. Okay, like if you want to create a front end of your robot application or the robot, you can use web packages. Like there are some libraries of ROS, like ROS client, I can say, for the JavaScript. Okay, so there are some libraries like ROS2.js, ROSLibJS, ROS3D.js, something like that. So you can make use of that library in your web page, and then you can create the application, and when you move the robot from your website or the web page, the real robot will move. Okay, so this is like a front end application. Currently we have the React JS. So using React JS we can create the same thing, but React is somewhat easy. You don't need to code from scratch to create an application, and you can use the ROSLibJS for creating the ROS interface. Okay, so these are some of the projects that I have done. I can quickly, I can go through some specific projects. I know it's very difficult to discuss all the projects, but maybe I can discuss some chapters that I feel good about me, writing, because I have done a lot of work in writing. One of the chapter will be the self-driving cars. Yeah, this one. So I have create an abstract of the journals that I have read about self-driving car, and I think, yeah, this is one company from my friends, not my close friend, they are professional friends. Yeah, so they created a company called Oro Robotics. So this is a shuttle actually they created. Yeah, and yeah, I think I have mentioned the important sensors that we gonna use. Then yeah, most of the sensors, then a block diagram in a self-driving cars, what are the important stuff that we can see in the software. Then I have discussed how to simulate all these sensors in a self-driving cars, like simulating 3D LiDAR, 2D LiDAR, then IMU, cameras, stereo cam, all these things are like discussing. Yeah. Yeah, so Tejas is having question. Aura is still functioning. Okay, Aura actually acquired by another company. So you can simply search Aura Robotics. So they acquired by another company. They are called RightCell. Okay, now they are called RightCell. Yeah, so this is still running. Okay, so I think, yeah, I'm not sure how successful they are, but yeah. Okay, yes, so that is the thing. So I'm discussing all this and getting back to, you can also check, guys. I'm just yeah, and the VR headset, that stuff I actually liked. This is ROS VR, yeah. So here is the stuff. ROS VR application with Gazebo. So you can see here there is an application from Android, and you can see the image. This book actually written when I was doing masters in robotics in Amartya University. So this is my hostel actually. And you can see here I have used the Turtleboard simulation, and in Turtleboard simulation we have a depth sensor Kinect, okay, and from that we are getting images. So I was basically using that image and put that image left and right, and yeah, and then I was using the leap motion to control the same. Okay, so that was one project, and before that let me check. Yeah, this is the ROS Android app, like publishing, subscribing from Android phone. So yeah, so you guys can check, because some of the contents are not valid because it's done for previous version of ROS. Okay, this is for the MATLAB, controlling the robot from the MATLAB. Then 3D 3D object detection. This is the 3D object detection, yeah. Yes, so yeah, so that is the list of projects. So I discussed the title because you can also think in this way. I mean, if you want, like there are some interesting technologies that we can combine like this to ROS. Okay, so I have combined multiple technologies like VR, then Android, then AI, deep learning, all this stuff. So you can also think about different things. So you will get to use used to these technologies. Okay, so that is one book I want to show you. Then the second edition. So second edition actually done with Noitic, I think. Okay, it's latest one. So for this book, I didn't have much bandwidth to write a book at that time. So I seek help from one of my colleague. Actually, um, the publisher actually connected with Ramkumar. He's actually the uh, main person main person in the sense, I think he's a tech lead or manager in Wipro. Maybe you can check his profile. He's working on robotics and currently he's in US. So he is working on ROS and he's having much better knowledge compared to me. So he's working on robotics, and he actually collaborated for this project, having same kind of experience, but I think he's having more knowledge compared to me. So I think yeah, he is also having masters from SRM, and then he's working on Wipro. They are working on some. Wipro is also working on like the self-driving cars and all. Okay, So you can see here he worked with a lot of project autonomous cars. Then yeah, currently he's working on social robot interaction, SLAM models. Um, yeah, I think he's in US, I guess. Yeah, yeah, Mountain View, California. Yes. So he's the co-author of this book, and I couldn't contribute much, but he also like updated a lot of content. So first chapter, I think it's almost the same. I mean, he tested with 18.04, but it's also compatible with Noetic, I guess. And also he mentioning about ROS 2. Uh, this chapter I think happened in 2020, 2019. So at that time, ROS 2 was there. So he mentioned about ROS 2 and then an industrial manipulator project, basically having a robot base and manipulator on the top. Then some task with state machines. Then again an industrial application with some intelligence. Then multi-robot collaboration. That is SWAM robots basically. Then some ROS on embedded platform like STM32, Arduino and all. Then ROS on Tinkerboard, Raspberry Pi, all the stuff. Then reinforcement learning and robotics. Then deep learning using ROS. I think these are all chapters. Then self-driving car, teleoperation. Yeah, these are some of the old projects. And he's also having an Alexa project. I think that is in this book, like in the interfacing Alexa and ROS. So I think there was one chapter regarding it. Let me check. Yeah, this is the industrial robot mobile manipulator he have done. And there was a ROS 2 chapter. So in that, I think he's mentioning about the basic stuff of ROS 2. He's showing ROS 2 in Python and also C++, I guess. Yes. At that time, ROS 2 was, what was the version? Just a second. I think it's not Foxy. I think just Crystal, I guess. Crystal or something. Let me check. 18 dashing. It was dashing. Yeah. He worked with the actually dashing, yes. So there are some cool projects, but most of the projects are like mobile manipulation that you can try actually. These projects are done from the scratch, so you can check it. There are some simulations. I'm not sure it is completely working on Noetic, but mostly like if you do some minor changes, I think it will work. Yes. Yes. So that is the second book, guys. He actually mentioned most of the stuff in this book from his experience. Okay. So these are the two chapters, guys. So this is one reference I would like to give you. And also there is another book called ROS Robotics by Examples. Again, there are some projects mentioned. The projects maybe we can simply check. And after that, I will say, after this session, I will say like, please look onto these two books and think about some latest ideas, and maybe you can also try to do or modify these projects that is mentioned in the books, or you can think about some changes. Okay, some changes. Maybe you can do a lot of stuff using ROS Android, then VR headset, then what, IMU, gestures, I mean using depth camera, skeleton tracking, all this stuff you can do. You can integrate with ROS. Then using vision you can do stuff, OpenCV, right? So this chapter, I mean this book, ROS Robotics by Examples, I think they are talking about, yeah, basic robot, turtle boat, navigation, first robotic arm, wobbling robot arm using joint control. It doesn't have um, projects, but I will say some learning. Uh, I mean, creating a new mobile base, new robotic arm, then drones, then working with MATLAB, something like that. Okay, but also you will get something from this book as well. I think I have reviewed this book, I'm not sure. Or this may be something else. Let me check. Was the author? Okay. Second edition. Yeah, I have reviewed this book. Yeah. Okay. So, yeah, that's it, guys. I think you can think about the projects from these two books, and the repository is also available. Maybe I can share. Just search for ROS Robotics Projects GitHub. Yeah, so these are the code that is available. Now the second edition. Okay. Yes. So that's the thing, guys. I think we can conclude for today. I'm not also not very well. So maybe we can switch to the Q&A if you have anything to ask related to the projects. So let me know if you have any question, guys, related to the projects. You can just go through this book first and let me know if you have any questions. You can also plan for some projects. That is what I am also suggesting. Yeah, let me know if you have any questions. Any questions? This is the ROS mobile app in which you can connect to the ROS system, and then you can publish stuff, whatever the topics, and you can control your robot using this app. Okay. Yeah, so there is a question from okay. Yeah, so Rohan, thinking project. Yes. Okay, so maybe if you want to discuss privately, then we can do. Maybe I'm not well today. Maybe tomorrow, maybe after the class, we can discuss. I think that will be good because my voice is not good now. Maybe tomorrow. Okay. Yes. So I think that's it. You can just go through it, and then if you have any questions, let me know. Okay. So if it is related to any projects mentioned in this chapter, I can clearly explain. Okay. I will not say you can replicate the same projects in Noitic, But what I am trying to say is like you can do this kind of projects. Okay, cool projects, and the advantage of doing cool projects is that it will get so much attention from the community. Okay, and also you can, I mean, the learning will not be boring. Like when you try to learn something, obviously, um, it will be somewhat boring. For example, if you are working with ROS and you are working with uh, some differential drive robot, okay, but there is no fancy about it, like just a differential drive robot. But if you are doing some cool stuff, then you will have a motivation to pursue it, and with that motivation, you will learn stuff. Okay, so you can try to find some cool projects. Okay. Okay, guys, I think we can conclude. So tomorrow, I think we can discuss some part of the project, and we can jump into maybe some other topics. Let me check. We can discuss with the Docker or some other concepts. Okay. Okay, guys. Thanks for attending. See you tomorrow. Bye.